Hello, my name is Emily Bache from Bache Consulting. This is a presentation introducing test-driven development, mostly about the theory of it. I have a follow-up presentation with a demonstration, but this presentation is more about what it is and why it works and why you might want to use it. So test-driven development is a disciplined way of working that programmers use that leads to a higher quality systems with good design, and along the way, you create an automated regression test suite with good coverage of your functionality. So this changes the way of working at a minute-by-minute level, and these benefits are reported by practitioners who use this way of working. Now, this regression test suite of automated regression tests is for catching errors. When you change code, you want to be able to check that you haven't broken anything that should be working. And this is a very useful thing to have in a system. It makes it much more maintainable. It also, the tests provide documentation and examples of usage for your code. And just by having these kind of unit tests or unit checks, they force you to have internal APIs, interfaces, and units in your code. And that in itself is a good design characteristic for a piece of software. So I think everyone agrees that it's a good thing to have automated regression checks and tests, unit tests, for your software. But there's different ways of working that will all produce this suite of tests. I like to characterise them. These are obviously extremes, but the test last way of working and the test-driven development way of working both produce this kind of regression tests. But if we look at test last, this is where the programmer sits down and first starts writing some code. And then when they think it's working, then they start creating the unit tests or the checks, the automated checks, to test that what they've written actually does what they think it does. And sometimes, or quite often, they'll find that maybe it doesn't do what they think it does, and then they end up doing some debugging to get the test to pass. And then they write some more code. And this way of working obviously will lead to some tests, but I don't think it will lead to such high-quality tests and as good design as a test-driven development approach, which is the other extreme, where instead of starting by writing the code, you start by writing the tests, the automated checks. And then when you've actually completed writing a test, you actually move on to trying to write the code that will make it pass. And then when you've got it passing, you refactor your design to improve it. So both these ways of working will actually produce these regression tests. But I'd like to explain more about test-driven development and how it works, what it is, and why it might be superior to a test last way of working. So if we look at TDD, I like to explain it in terms of states and moves. So I've got 4 states here, and there are moves, the legal moves to move between the states. So I already mentioned red-green refactor, which is the kind of core cycle you go through in TDD. But I like to also introduce another state, which is this overview state, where you step back a little from the code and work out what it is you're trying to achieve. So most of the rest of the presentation is basically going through each of these states. So if we look at the overview state, this is where you're trying to work out the context, the analysis of the problem you're trying to solve. I'm sitting down to write some code now. I might be aiming to sit here for maybe an hour or two, or maybe a day, or maybe this functionality is going to take me a week to build. But at some point, quite often I need to step back and reassess, where am I? What problem am I trying to solve? What existing code is there? Where am I going to call my new functionality from? Where does it fit in? Can I set up an acceptance test, a guiding test, which will tell me when I've got the whole feature working to the point where I can hand it over to someone else to use or test or look at. And it might be useful to define that actually in a testing tool, automated testing tool, or it might not. But in this step, we're trying to work out what problem we're trying to solve at a slightly larger scale than the kind of tests we write when we're doing the red-green refactor cycle. But as part of this step also, we might be starting to make a plan for a list of the unit test cases, the small micro tests that we're going to need to write in the process of building this functionality. And it can be quite useful just to make a list of those on a piece of paper and keep it next to you. So this is the overview step where we're trying to work out what we're doing, and you know when you're ready to move on to another state when you think you have an achievable goal and you've chosen the next micro test that you're going to try and implement, the next small unit test. So then we go into the getting to red state, and this is where we're concentrating on creating a test case that's going to fail. So the test case needs a name. It needs often these three parts of a test. We'll almost certainly need an assert statement, and some people find it useful to actually start with that rather than the name of the test, and to actually declare, well, when this test is passing, I'll know that's a good thing because this assert statement will be true. And that will lead you to know, well, then, okay, what objects am I going to need to create before I can get this functionality to do anything? And then the act state is where you actually call the method on the object that you're trying to check in the assert step. So this is about creating the test. And while you're doing this, if you're working in a compiled language, you might find it helpful to write a small amount of production code so that the compiler helps you and your IDE supports you in what you're doing. But you should only write the absolute minimum of production code. The focus here is on writing a good test. And you know you're ready to move on when you've got a test that describes the functionality you're trying to build, the small increments of functionality. The test executes and it fails, it's red. And then you move into the getting to green state. And this is where your focus leaves the test and we move to the production code. And we have to write just enough production code to make that test pass. And to do this, you can take shortcuts. You can duplicate code. You can write code that you know is in the wrong class, it's in the wrong place, but you can't quite see yet where it should go. But the idea is you want to get that test to pass as quickly as possible so that you can review your design from a position of strength, from a position of passing tests. One technique you can use is fake it. I haven't got really time to explain that yet, but it's a technique you can use to cheat, basically. And if you, after all that about hacking it and cheating, you really still can't find a way to make the test a pass, then you've probably written a too big test, too difficult micro test. And at this point, a legal move is actually to comment out that test, ignore it from your test suite, so you get back to green, and then you can go back to the getting to red state where you write a simpler, easier test that you can try and get to pass instead. But ideally, from this state, the next state should be the refactor state, and you should move on to that when you've got your new test passing. It should be green. So the refactor state, this is where just minutes after we made those hacks, those shortcuts, we clean them up. In the refactor step, we want to make our design good. We want to move the functionality to the right place. We want to get rid of any fakes that we put in, code smells. We also want to review the test code and see whether we need to improve the readability there. The trick is not to add new functionality that isn't covered by tests, and to keep the tests green. In this step, you might also note down more test cases while you're looking around the code. And you know you're ready to move on from this state when your code, you're happy with your design, the tests are all executing and they're all passing, they're green. So that's, in a nutshell, test-driven development in terms of states and moves. And you should find that you're hopping back to the overview state fairly regularly while you're coding, so that you're always keeping in mind the big picture, the overall aim, as well as the little, in the red-green refactor cycle, you're concentrating on the minute details of the exact class and methods that you're working with. So this method done well should give you plenty of opportunity to improve your design and plenty of feedback on your the system you're building in the red step before you've actually committed to an implementation. But it isn't a silver bullet. I like this quote from David Chiepak, where he says, TDD is not a silver bullet. It is a very helpful feedback mechanism and source of constraints, but is not the only one. So thank you for listening. My name's Emily Bache. I hope you'll be interested in my other presentation too.